This is our Unit 1 Assessment Study Guide. So our test is on Friday, and this is what you're going to take home to study. I'm going to send you home with a blank copy so you can use it to fill out on your own and then check yourself with this copy we're about to fill out. Okay? So the first question says, is 27 a prime number or composite number? Explain or show your reasoning. So in order to determine if a number is prime or composite, we have to know how many factors it has. If it has just 2 factors, one in itself, it's what? Prime. Prime, short list, 1 syllable word, prime, 1 factor pair, 2 factors. If it has 3 or more factors, it's composite. Okay, so for 27, we start by writing down 27 and the first factor pair of 27, which is 1 times 27. And the number that comes after 1 is 2. Is 27 divisible by 2?
No.
No, because 27 is
Prime. No, composite.
what kind of number is 27? Even or odd? Odd. So 27 can't be divided by 2 because it's an odd number. Can 27 be divided by 3?
Yes.
Yes. If we look at our multiplication table and we go to the 3 row and find 27, and then we go up, 9 is 3's partner. We don't even have to go further than this because we found that 27 has 3 or more factors, right? It has 1, 3, 9, and 27. So that means 27 is composite. All right. So write down 27 is composite. Because it has 3 or more factors. There's not a lot of writing on this, but you do have to keep up so you won't get behind. 27 is composite because it has 3 or more factors. Start copying. Everything I write, you write. On B, it's wanting us to look at the number 29. So if you guys look at your multiplication table, if you're finished writing, then you can go ahead and look at your multiplication table. If you're still writing, you can keep going. Do you see the number 29 anywhere on your multiplication table?
Nope.
So we always start with 1 times the number itself. And then, can 29 be divided by 2?
No.
No, because it's odd. Can 29 be divided by 3? If we go to the 3 row, is there a 29?
No.
4 row?
No.
5 row?
No.
6 row?
No.
7 row?
No.
8 row?
No.
9 row?
No.
So 29 is prime. If we keep getting no's to all those questions, that means it only has 2 factors, 1 in itself. 29 is prime because it only has 2 factors. If you want to add on, you can. rewrite that part. Because it only has two factors. You're gonna have to keep up, okay? 29 is prime because it only has two factors. Oh, you're doing that. Good, Todd. Okay. 1 and 29 in parentheses. All right. On the next, on question 2, there's 5 ones or 5 problems, and it says select all the true statements. That means you're probably going to select more than one if it says select them all. So the first one says 15 is a multiple of 3. If we are counting by threes, will we eventually say 15?
3 times 5.
So here's what we're going to write. We're going to circle it because it's true. And we're going to write 3, 6, 9, 12, 15, dot, dot, dot. That's how we know that 3 is a multiple of 15. Because we're writing out a list of the multiples of 3, and we see 15's on there. The next number, or letter B, says 16 is a factor of 8. So if you think about the factors of 8, 8 goes on top. And I'm going to write it over here for B. 8 goes on top. So we start with 1 times 8, then 2 times 4. Is there a 16 in that list?
No.
No?
Can we just leave it blank instead of crossing it off? It's like leave it blank.
Nope, just do what I'm doing. Because that says that we looked it over and found that it was false instead of we just accidentally missed that one. But write the factors of 8 over here. And circle them, don't blot them out like that, okay? Because then you can't see a letter. Okay. C says 80 is a multiple of 4.
No.
That one's kind of hard because 80 is a long way from 4. But, watch this. 4 times blank equals 80. Well, first let's look here. 4 times what equals 8, Zerelda? 2. 2. And since we've got a 0 here, just stay seated, I'll put you a point down. Since we've got a 0 here, we just add our 0 here. So now if we count by 20, 20, 40, 60, 80. So 4 is a 80 is a multiple of 4 because 4 times 20 equals 80. Look at your multiplication table and see if you see a 49. Anybody see a 49?
Yes.
Yes.
Yeah.
What are the numbers that go together with 49? 7 times 7. Okay, so this, D says the only factor pair of 49 is 1 and 49. Is that true or false?
False.
Because there's also 7 times 7 that equals 49. Okay? So it's false because 7 times 7 also equals 49. And E says the factor pairs of 12 are 1 times 12, 2 and 6, 3 and 4. Is that true?
Yes.
Yes. That is true. That is all the factors of 12. Okay, you're getting way behind again. Okay, pick up your pencil. Where's it at? Okay. All right. At the bottom, there is a Zarelda. I wrote her name down so I remember to give you a point. Okay. The next question says, find all the factor pairs of 84. The number on your test looks exactly like this, except the numbers are different, okay? So, it'll say find all the factor pairs of, and give you a different number. I tried to choose ones that were smaller than, that were smaller, so you can use your multiplication table to help you. Here we go. 84. What are the first 2 factors of 84 chambers? 1 times 84. We're going to go in order so we don't miss any of them, okay? 1 times 84. Okay? Can 84 be divided by 2? Avis?
2 times 42.
Nice job, yes. 2 times 42, because what's half of 8? 4. What's half of 4? 2. Okay, is that how you figured it out, Avis? Nice job. Okay. Now, 8, what number comes after 2? 3. Your multiplication table doesn't go high enough, but I will tell you that 84 can be divided by 3 because there's this little rule, Cameron, that we're going to learn later that tells us if we add the digits together, what's 8 plus 4? Evan?
12.
12. Evan, is 12 a multiple of 3? If you're counting by 3s, will you eventually say 12?
Yes.
Yes. So that means 84 is 2. Okay? We're going to come back to figure out what 3's partner is. Can 84 be divided by 4? Yes.
Yes.
What's 8 divided by 4?
2.
2. What's 4 divided by 4?
1.
1. There we go. Nope, we just went.
I'm gonna.
Okay, well you have to wait. Okay.
Do that.
All right. 84. Can 84 be divided by 5?
Nope.
How come? How do you know, Jackson?
Because 84 is an even number and 5 is an odd number because there's a 4 and 84, so it'd be even.
So what if it were divisible by 5? What would it need to have in the ones place, Jackson?
It have to have a 85 or something like.
Look at your 5 row of your multiplication table. What's in the ones place of all those numbers?
5.
Or
10. Wait, no. 0.
0. So this is what I'm saying. If you look at your 5 row, what's in the ones place? 0, 5, 0, 5, 0, 5. And it keeps going. What is in the ones place of 84? A 4. So 5 is out. And I'm going to tell you that if you, something to know for later is if you have a number that has a factor of 2 and a factor of 3, you automatically have a factor of 6. And you guys have on your multiplication table this one. Colton, go to the 6th row and find 84. And then go up. What's its partner? 14. Good work. Okay. Then, can 84 be divided by 7?
Yes, it is.
What's 7's partner?
12.
12. And can 84 be divided by 8? No. 9?
No.
No. So we've got them all. Okay. So now, except for, we didn't ever find 3's partner. I haven't taught you guys how to divide big numbers yet, but what you can do is say, I know that it's 3 times something equals 84. It's going to be a bigger number than 21, but smaller than 42. So let's just pick 25. 25 3 times. So think about quarters. What's 3/4 equal? Shout it out.
75.
75. So 25 is not big enough because we need to get to 84. So let's try 27. So what's 7 times 3? 21. So what should our number be? And not 27, but 28, because we need one more from each group. So 3 times 28. So watch this. 28, 28, 28. What's 8 times 3?
24.
24. 2, 4, 6, 8. So that got us to 84. Okay, so here's our factor pairs of 84. We got to write them all down. 1 times 84. 2 times 42. 3 times 28. 4 times 21. 6 times 14. And 7 times 12. Like I said on your test, it will be a smaller number than 84. Pick up your pencil. You gotta copy all those factor pairs down. I would rather, going forward, that you like factorless like this, because it's a number thing. I'm not gonna be erasing, but, yeah. All right. If you didn't get all of that finished, they are right here. I'm gonna flip to the next page. Okay, and we've got Han is playing a card game with some friends. The number of cards never changes, but the number of players does. It's right here, Devin. Okay? The number of cards never changes, but the number of players does. So, with 5 players, the cards can be divided equally between the players. Could there be 50 cards? So you got 5 people, and you need to stop. You've got 5 people and 50 cards. Would that work? Would they all get the same amount? How many would they each get, Autrey?
10.
10. So we go 10, 20, 30, 40, 50. Yes, that would work. So here's what we're gonna write. Could there be 50 cards? Yes. Because 5 players times 10 cards each equals 50 cards. Write that down. There's some of you not writing. Good thing to do is while I'm writing, you write. So it could be 50. But then it says with three players, the cards could still be divided evenly. Could you divide 50 by 3 evenly? Look at your multiplication table. Go to the 3 row, it only goes to 45. So 45 plus 3, 48. 48 plus 3, 51. 51. So we cannot, there cannot be 50 cards if 3 players can split them evenly. Because 50 is not a multiple of 3. No, because 50 is not a multiple of 3. Okay? So if I'm counting by 3s, I'm never gonna say 50.
Wait, we'll say 50.
But I'm never gonna say 50. Okay, did you get it, babe? Okay. All right. Last question. With 4 players, the cards can be divided equally between the players. How many cards could there be? So what we know now is when there were 5 kids playing, they all were able to split them evenly. When there were 3 kids playing, they all were able to split them evenly. And now when there's 4 kids playing, they can all split them evenly. Do you remember when we talked about common multiples or common factors? Things that people have in common? Who's got black pants on today? Zerelda. Okay, so don't stand up. Me and Zerelda have black pants in common today. We're both wearing black pants. Okay, so we're gonna look for a common multiple between 3, 4, and 5. One way to do that is to multiply 3 times 4 times 5. So watch this. What is 3 times 4?
12.
12. What's 12 times 5?
62.
Nope.
60.
60. 60. Okay. So watch this, guys. If we're counting by 3s, 3, 6, 9, 12, 15, blah, 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 blah. Eventually we're going to say 60. If we're counting by 4s, 4, 8, 12, 16, 20, blah, 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 blah. We're eventually going to say 60. And then 5, 5, 10, 15, 20, dot, 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 60. On all of those, we're eventually going to say 60. So this is all I need you to write down on that one. There could be 60. There could be 60 cards. Because 3 times 4 times 5 equals 60. And 60 is a common multiple start with 1 times 60, 2 times 30, 3 times 20, 4 times 15, and 5 times 12, and 6 times 10. So right there on the factor list for 60, do you see a 3, a 4, and a 5? So if there's 3 players, how many cards are they each getting? 20. If there's 4 players, how many cards are they getting, Zerelda?
15.
And if there's 5 cards, how many, or 5 players, how many cards are they getting, Ari? 12. Okay, does that make sense? Okay, so go ahead and finish copying that down. If you are on this problem on the test and you're having trouble figuring it out, just multiply all the numbers together, okay? Because that will help you. Or you can list out the multiples, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, there it is. And then 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, there's 60. And then 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Okay? See, if I keep counting all those multiples, eventually in all 3 lists I got a 60. Yes?
Do we have to write that?
You do not. So, but if you're on the test and you're having trouble, you can, to help you see what the common multiple is. Okay. I'm going to stop the video so it's done, and then if you haven't finished, I'll leave it up there so you can finish copying.